and jump out of Tinkercad and go back to the good old ones and zeros. So if we have, let's say we have X and then we have Y. Okay. Are we all, if yes, you simply say yes. Are we all familiar with the AND gate? If yes, please say yes. Okay, so quick recap and then we'll go on. So I'm getting a lot of yes and some no. So here's the thing. If we say Michael and then student. So for Michael to teach, both Michael and the students must be present. So if we say we put teach, and we say a 1 means teach, a 0 means do not teach. So Michael is here, the students are here today, Michael will teach, right? So it means 1, 1, Michael is here, the students are here. If Michael is here, so Michael, then students with 0, 0, 0, 1, 0, 1, and then you have 0, 0, 1, 1. So if Michael is not here and the students are here, there's no point to teach. So T will be 0. Michael here, not here, the students are here. There's no point to teach because obviously there's nobody to do the teaching. So that will be a 0. Michael is here, there is no student. There are no students, then no point to teach. And then also, if we are both here, then we teach. So an AND gate means both states must be asserted or must be valid in order for the output to be valid. Right. Now if we have X, that's your entry into the AND gate. If you have X and then you have Y, and let's say you have 8 bits on it. 0, we can insert a 1, 0, 0. Okay. Remember, for the output to be 1, both states need to be 1. So we don't really care what is here, we don't care what is here, we don't care what is there, we don't care what is there, but we are interested in, well, let me cancel this. In our case, we are interested in pin 2. So don't care what is there, what is there. If we put a 1 here, the output will be 0 anyway. If we put another 1 there, the output will be 0. It doesn't even matter. So if let's say we keep this 0, 0, 0. If this is a 1, we are forcing the output to be 0. If this is a 1, we are forcing the output to be 0. But if we make sure this bit is 1, we are forcing the output to be 1. So by doing a bitwise AND with, we have the known, which is X, and then we are doing AND with the unknown, with the, well, we have the known, sorry, which is Y. That is what the bit we are interested in. And then we have the unknown signal in, which is X. So we simply interested in pin 2. We say, okay, we put a 1 on pin 2 and everything else 0. If let's say the state of the pin we are reading is 0, this output will be 0. If it is a 1, the output will be a 1. So for somehow we create a means of isolating this particular pin from the rest. That's why we use this AND. All good? Yes, yes, yes. Let me know you're alive. Good. So what you notice is that the same code, not much have changed, but if I press it, it just lights now. Still similar stuff. Now we want to improve on even this expression more because it's quite difficult to read all the ones and zeros. You notice I even struggled to write it. But we have the button pin, which is pin 2. Now we've got the pin that we are reading from, where in our case, sorry, I need to share my screen. Right, so we've got